Okay, dokie dokie doo. Yellow, everybody. Hope you guys are doing well. Can you guys hear me? Everything looking good? Sorry, I have another laptop from work open here, just in case I get any messages or anything. So, I'm just in that, working towards that. Too many things going on. Where is Wrench? Where is Wrench? Where is Wrench and Rover? Yo, oh, things now got updated. Shriram, what's up, bro? You're okay. Sorry. Yeah, dude, like it just got updated. You guys saw it. Like you guys didn't see it, but this thing recently got updated. Howdy, Radhe. Sorry, I have like on the left side, I have my laptop open for like stuff like happening. If I get any messages, right, from the company and stuff. And then I have you guys. So, which is also awesome. I'll take this off. And then we'll get started. We actually have a little bit more time today. So, we will try to cover up task 4, IP addresses, UDP, TCP, 2 of these for sure. So, let's see. I have no idea, bro. Be a good guy. There are a couple of things necessary for that. First, like you have to have one of these things. First, rich. Are you rich? No. Work hard, be rich. Are you handsome? No. Work hard, be rich, get a plastic surgery. 2 things are required. Or you just need to know about the girls she hate. Right? You just really need to know the girls she hate so you can talk to her. She feels really like comfortable with that. Three things. You need one of the 3 things. Money, paisa, right? Either you need money, looks, or basically information, data. Third, I think you guys can get. Third one, you have like the best chances in. It's very nice. Especially if you have more information than her. It's really nice. It's really fun to talk. That's all I will say. एक भी आ जाएगा भाई. Yeah. Howdy, Rover. Good morning to you. Okay, let's get started with IP addresses and subnets. You guys can see my screen. Do you want me to make it bigger a bit? This is good. Hopefully. This is good. You guys, like my audio is good. You guys can hear me and everything is fine, right? Or you want me to make any changes, quick changes before I get started? Because today we'll do some learning for a good 1 hour. It's just learning. Yeah, okay, awesome. Okay, so let's get started with task 4, IP addresses and subnets for networking concepts. When you hear, no, you guys can hear me, I can see here. I just want to make sure it's clear enough. So, IP addresses and subnets. When you hear the word IP addresses, you might think of addresses like 192.168.0.1 or something less common such as 172.16.159.243, right? Hey, Shriram got you, bro. Exactly, that's actually right. So in both cases, you are right. Both of these are IP addresses, IPv4 addresses to be specific. Every host on the network needs a unique identifier for other hosts to communicate with him. So basically, if you want to send to have communication happens when one host one device sends packets to another device. Basically, let's say almost like letters. If you want to send letters to one house from your house, you need addresses, and they should be unique all across the world, right? So if you're wanting to send in India, it should have just India at the very end. That's that's the whole same concept in the terms of computer and internet. Every host needs a unique identifier, address, so that other hosts can talk to each other, sends packets. Without a unique identifier, the host cannot be found without ambiguity. When using TCP protocol suite, we need to assign an IP address for each device connected to the network. This is only in case of when you are having a TCP IP protocol, like a IP to IP communication. Because in some you don't need stuff. One analogy is of an IP address is your home postal address. Your postal address allows you to receive letters and parcels from all over the world. Furthermore, it can identify your home without ambiguity. Otherwise, you cannot shop online. That's actually a good one. As you might already know, we have IPv4 and IPv6, the version 6. We don't have any version 5, 1, 2, 3, just 4 and 6. IPv4 is still the most common, and whenever you come across a text mentioning IP without the version, we expect them to mean IPv4 because that's the default one as well. And let me show you something. Let me open my this profile. 1 second. I'll show you something. I'll show you guys my IP address. So when you go to a website which talks about like something like what is my IP address, right? It will be, for example, for in my case, it would be this IPv4. A lot of you might have both. You can have both together, IPv4 and v6 connected to one machine, or can have just one, but you need at least one. Can have both, but you need at least one. Okay, we had this. So, what makes an IP address? An IP address comprises 4 octets, 32 bits. So 4 octets. Octets are like I think, what's the meaning of octet properly? Like, I don't remember octet meaning properly. Sorry. Being 8 bits, an octet allows us to represent a decimal number between 0 and 255. Okay, there we go. I think 8 bits will be byte. Being 8 bits is... Oh, really? Just 8 bits means an octet? I thought that's like a byte. Is byte and octet same? Octet allows us to represent a decimal number between... Oh, using bits, it just allows us when we use 8 bits to represent a number. That means it's octet. Okay, thank you, Shira. An IP address is shown in the image below. So octet 1, 0 to 2. So minimum value 0, maximum 255 for all 4. At the risk of oversimplifying things, the 0 and 255 are reversed for the network and broadcast addresses respectively. In other words, like for example, if there is a network you are on which starts with 192.168.1, 0 at the from the start is for networking address, right? It is like when you want to talk is for devices and couple of other things. Whereas there's something called a broadcast, just like radio don't know your IP address. It doesn't care. It just sends signals. Your antenna catches those signals. That's the same concept. This address doesn't care about your one. It just wants to send message to all the ones which are ready to receive. It will just send a broadcast message across the whole network, and the ones that want to receive it will get it. Sending to the broadcast address targets all the hosts on the network with simple math, you can conclude that we cannot have more than 4 billion unique IPv4 addresses. So 255, or basically 256 because including 0, 256 times 256 times 256 times 256. Let's see. So 4 billion, I think. Hundreds, thousands, million. So 4 billion. Yes, this is a private IP address. Yes. The one starting with 192 is private. Yes. If you're curious about the math, it's approximately 2 raised to the power 32 because we have 32 bits. So a 1 bit can have two values, zeros and ones. This number is approximately because we didn't consider network and broadcast addresses. With the broadcast address is the last one, and the network's address itself is 0. I'll give you a good idea with the picture, I think. Where's Sebastian? Okay. I will say the way they are mentioning, at least in this case, is this. Ooh, nice. You know what? I love this auxiliary draw. Really good. Okay. So we have the IP address in a network. We have this, and we have significance. This is, I think, important to remember because, like, it's useful in real world, actually, in my opinion. So the first address we have is the one that starts from 0, the very first address. Dot 0.0. Let's say 0.0, right? This one. Then there's this one. Then there's this one. Remember this image here. This will help you big time. There are 3 categories. First one is the network address itself. What does you mean by the network address? Let's say you're living in a society, right? There is each house has in a society. There are multiple houses, right? Let's say every single circle is a house, and this is a big society with like buildings or whatever. Each building or house will have its own address and stuff, right? It could be like, let's say, Apex Society or Apex Apartments. When a letter is addressed, it could be like, okay, it's addressed to somebody in building A, B, C, and D. But sometimes because it's an apartment, there would be like, services as a collective, they want things, right? All the people, residents of this apartment want certain things like garbage cleaning, electricity for the street lights, right? Then who should we send the bills to for those? We send it to the apex apartment, right? So this itself will have its own address. That's the same concept here. We have the first one address. This is for the network itself, the whole network that contains all the 256 addresses. These ones are, let's say, the houses or each device. Last one is a broadcast. Like there would be like let's say a notice board here, right? Notice board in the society. So anyone who comes near the notice board, reads it, will get what it's talking about. So this is more like the notice board or the broadcast address. Whoever comes near or wants to get the information, the latest information from the notice board, will get it. So that's the three types of addresses inside a proper subnet or inside a proper network. Is that does that help understand what they were talking when they said it's a network address? It's the society network is like almost the society's address itself. Okay, good. Thank you. Because it when I was doing this and I asked like what is the meaning of network address, my professor never gave a good explanation. I think it was a friend who gave me this explanation. I was like so glad. This didn't make sense at all, like what these guys were doing. Okay. Now we have 192.168, right? Sending the broadcast address targets all. Wrench is gone. Oh, good night, bro. Good night. Have a good one. We'll see you in the morning because it's Friday night for me. We'll do lead code, a lot of lead code, and tomorrow I will still be coming online because I wasn't able to do many streams this week. So tomorrow I will come online at a better time and we'll do longer stream. Hopefully that works for you. Okay, coming back here. Where was it? If you're curious about the math, this approximately because consider network and broadcast addresses. Looking up your network configuration. 1 second, lads. 1 second. I just got a message from a manager. I'm just sending something on the side. I don't want to lose the job right now. Sorry, just give me 1 second, lads. Just give me 1 second. Okay, done. Beautiful. Okay, going back. Looking up your network configuration. You can look up your IP addresses on the Microsoft Windows command line using the command ipconfig. Let's start with like the tag box and we'll do it there. But let's say if you're using Windows, right? Where is that? Okay. So let's say if you're using Windows, if you open the command line here, I don't want to open it like, or I don't want to type it because it will give a lot of my information. So but if you type here in the command prompt, you will get all the networking information required, right, about your current system, the current host you run this on, right? We'll do it in the attack box once this is ready. But for Linux and Unix based, basically the Mac and Linux, if you open their terminal and type ifconfig instead of ipconfig, you will get the same information, or IP address show. That's another one which you can type as IPAS, but I think remember ifconfig because that's the one used. I hardly have seen IPAS. In the terminal window below, we see for Windows, I believe. No, this is ifconfig, so Linux. So this is the machine name. We have their address. Then there is the broadcast address is there. Network mask, that's a special type of address. We'll talk later. So you see INET, right? And then INET 6. So IPv4 and IPv6 address. IPv6 address is way bigger, and we probably won't be able to have enough devices in the world to create a scarcity of IPv6. The terminal output above indicates the following. The IP address, the host IP address is 192.168.66 and 89, like we see here. Network mask address, we'll talk about this later, but this is another special one. And then we have the broadcast one, 66 and then 255. Let's use IPAS to compare how the network card IP address is presented. We have, let's see, okay, we have this information coming out. Link ether address, oh, this is the MAC address, data link layer or Ethernet, layer 2 basically. So this is the address. Let's try to find out what this this system is about actually. MAC address, originally prefix. So this is of a Semiconductor Taiwan Limited. This is the companies who this first part belongs to. NX Semiconductors Taiwan Limited. That's why never give your information online. So many things you don't know. I think this is the broadcast address for IPv6. This is just the last address. F is the last in there, just like we have 255 for IPv4. Alternate name. In it, again, IPv4 address, the broadcast address, and stuff. Much more information in this one. Then we have IPv6 address. That's it. So in the terminal output above indicates the laptop. This is the IP address, the broadcast address. Don't worry about this 24 for now. If you are wondering, a subnet mask of 255.255.255.0 can also be written as /24. The /24 means that the leftmost 24 bits within the IP address do not change across the network. That is the subnet. So what does that mean is, are you guys able to understand the meaning of these things, or? Okay, I think this will do the job. And just another one here. Okay. What did I did? Like this, look at this thing. IPv4. This is how IPv4 is, right? These are 8 bits right here. Sorry, one sec, class. Okay, these are 8 bits right here, right? Same thing here, 8, 8, 8, 8, right? So when we are saying, when try-hack.me is saying, right, /24, the last leftmost 24 bits within the IP address do not change. What it means is that whatever the value of left 24 bits are, right, which are these 8 plus 8 plus 8. This is 16, 24, 32, right? We are only concerned about these 24 bits. So whatever their value are, that makes 255, which actually is just 1, 1, 1, 1, 1, 1. These bits, like, because if you see, if you do this in bits, all these ones, 8 ones is 255 total. That's the value. So this won't change. But this last one, which was actually 255.255.0, this thing is 0. So what this is, total value of every single bit here is 0. These are all zeros, right? This can change because these are, if it had like, let's say 32, then these won't change either. But right now it has 24. This is our one. So only these won't change. If it had 16, then these ones can change, but not the first half. Right? Same thing with, like, let's say if it was 8 and then it was 0. It's all about the leftmost bit. And this is also called CIDR notation. Classless inter-domain routing notation, a compact way to write an IP addresses. Awesome. Thank you, Shriram. Have you guys been taught this in university yet or no? I don't think so, right? Like they even mentioned about bits or bytes yet. Just the school, high school, probably in high school you learn. I think like another topic here, which is a very interesting one. I believe there is a proper section about it. Subnets, no. Okay, yeah, they teach just there is no bits bytes till then. That's fine, I guess. You will learn a lot here, I guess. Then you will, by the third year, I think you don't even have to attend college. You will be like, just show up in this exams. That's how you will be. They covered bits and bytes. Okay, that's good. That's also pretty important for fundamentals. Okay, let's get into. In other words, the leftmost 3 octets, the 3 octets. First, putting it here, first, second, third are the same across the whole subnet. Therefore, we can expect to find addresses that range 192.168.66.1, 254, similar mention. Yeah, I think that's the same thing. They are talking about, like, basically we can find those things because last ending ones, last 8 can change. So here you see the first 3 octets don't change. It's just the 1, 254, 255, 0. These things are changing, not the very first 3 octets. And that's what happens in subnet. I will create a proper video just about subnet. I will do a proper explanation. I just need to create the material for it. Because subnets is like is something that even confused me in the start. It is one of those topics, but once you understand it, you will never get confused. I'll just type subnet. Private addresses. As we are explaining IP addresses, it is useful to mention that for most practical purposes, there are 2 types of IP addresses: public IP addresses, private IP addresses. RFC 1918 defines the following 3 ranges of private IP addresses. So this one, why there are 3 ranges and where you will see it. When you are actually like playing with your network, right? Your router might be in this address, right? And let's say if you want to set up a proper server at your house, you want more private IP addresses, this is your guy. Big companies have way more devices, so they might use something like 10.0.0.0, right? You can use them too, but a lot of them, if you actually work for a company or even at your university, if you check the local IP address of their system, it would be in this range. It's just they wanted to create a standard. There's nothing special significance about these numbers though, because they just wanted to create a standard so that if you are setting up, if somebody as a network engineer wants to go debug things, they know, okay, this is a private IP address, these are public IP addresses. That's just the main goal. Nothing super significant about 172, 192 or 10. We presented earlier an analogy stating that public IP address is like your home postal address. A private IP address is different. The original idea is that it cannot reach or be reached from the outside world. It is like an isolated city or a compound where all houses and apartments are numbered systematically and can easily exchange mail with each other, but not with the outside world. Let me put it in a way better way. Okay, this is a much better one. Forget about what TryHackMe said. Let me put it this way. Oh, nice pixelated image. Nice. Okay. Now we talked about that in outside world. Let's say this is your house, right? If you want to send an address, your house sends the address to the world, and you get it back with the address mentioned on the packets being your house address. It could be, let's say, 123 some street, Washington DC, something like that, right? But once you receive the mail, you realize like it might be for your wife, it might be for your kids, it might be for your sibling, right? Those things can happen, right? Let's say, just for the purpose of this thing, right? Let's say this is not just a bathroom, this is your room. Let's say my room, Bathroom is honestly one of the best rooms in the house. Let's say this one is your parents' room. This is your kids' room. This is your sister's room. This is your wife's room. This is your room. Oh, you did these? Nice, Ran. That's awesome. Howdy, Ghost. That's crazy. Nice. And let's say this is a broadcast room. Okay. So this is your room, parents' room, kids' room, your wife's room, sister room. I don't know why you and your wife have a different room, but your call. Now, let me explain what happens. This package came, right? This parcel came. Now, it could be addressed to anyone in your house. It could be you, your wife, your parents. Oh, hey, Sensor. Oh, yeah, howdy, bro. Hello, YouTube from Ghost. So we have you, your wife, your parents, right? Your kid. It could be addressed to anyone. But the outside world doesn't know what inside your house looks like. They don't know which room belongs to which person, right? They just know, okay, send this to the address, send this to this house, right? Yo, Ghost from Shriram. Nice. I like this communication. Now, you have received the package. Let's do some fun stuff. Now, if the package is about your, let's say, parents, internally, whoever sees the package will just put it in your parents' house. If it is to your wife, the person will send it to, like inside, whoever sees the package will send it. You, sister, kids, right? This is how things work inside. You see a letter. You see it's whoever is addressed to you, put them in their room. Now, if you want to talk to your parents, you don't have to go outside and send a letter. You can just talk here. This internal communication can happen very easily, right? What is a good one to? I picked the worst, I believe. Okay, whatever. If you want to have a chat with your parents, this is like a easy thing. You don't have to go outside in the world. I hate this. Sorry. Okay. You can, if you want, you don't have to send them a letter all around, right? You can just talk to them inside. If you want to talk to your sister about how annoying she is, you can do that. If you want to talk to your kids, if your parents wants to talk to your kids, they want to talk to your sister, how bad of a kid that has been, blah blah blah, right? So inside world, you don't need to communicate outside. Like inside, people who are inside the room, they don't have to like go outside to talk to the people inside. They just stay inside, get it done. That's it, right? But if anybody from outside wants to go, they have to ask. Let's say if a person come or a communication like whoever comes, right? If a person comes who wants to talk to your parents, they can ask any one of us and will be redirected. But they have to first come inside the house. Hopefully, it explains where I'm going with it. Right now, let's look a little bit again to the concept. Where is it? A private IP. So private IP addresses can communicate to each other, but they want to connect to the internet. They need to have a public. Yes, but they don't need to have a public IP address. They need to know the address of their house they are in, right? The public IP address is the address of the house. Sorry, I had a brain lag right there. If, oh, thank you. So if I want to talk, my kids, my parents want to talk, right, to the outside world, they have to say, hey, this has to go outside. So what does the outside world know? Which address does the outside world know? They don't know your room address. They don't know your parents' address, kids' address. What they know is the address of this house. They know the address of this house, right? So, what they have to do, they have to address to this house. They have to like write a letter, and same for you. When you have to write on your to and from, you mention, okay, this is the you mention the house address, right? In case of from, you don't mention your room, you mention your house address. Your house is basically the public IP. Your house is a public IP, but and other houses. But when you go inside, right, your room is your private IP. Only the people inside the room, like your parent, you, your kids, your sister, your wife, broadcaster, like forget about the broadcast for now. But like only these people know what your room looks like, what is exactly your room, right? Only people inside know which room is yours, not the outside one. Same game is here. Only the devices inside my house which are connected to my Wi-Fi router knows how many devices are connected to the router, what is their public private IP addresses. But in case I actually now I can explain you with router. Okay, this is the case now. Same idea, remember, right? Let's say this is your wife working on her laptop or computer. This is you. This is somebody like your sibling or your kid. And these are other devices. Let's say other person, whatever, right? You get the idea. Now, if I want to send or talk to anyone in the world, how things will work is that I send a message to the router, the big gate, right? Remember, the gate, the router is basically your public IP. Yes, 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 exactly. Router is the one with the public as well as a private IP. This is almost like a gate, right? Public IP, this is legit your house. Yes, this is the one which is like a gateway. All the messages, right? Just like I was saying, your house, there is a postal outside your house, right? There is a post box where like a postman can collect. There is a door, a postman can like a postal one, right? Your door can they can collect the postal packages, letters, whatever from this place, right? And if they have to deliver, they deliver it here. That's the same thing. That's that what's it called? Post box. The post box is basically your router. This thing has knows inside people as well as the outside people, and this is like the one gate to talk to the world. You send a letter to the modern, or like let's say you want to talk to the Facebook. You tell the router, hey, can you get me the Facebook data? Sends to the internet. Internet doesn't know which device is yours. It just knows that I just have to send this to router and the router will do the rest. Router says, yep, I know where he is. Same thing here. Hey, give me what are my emails look like. Goes to the internet, comes back. Does that like gives you an idea what subnets are about? Does it help, or you want me to a little bit do more explanation, or maybe I can come tomorrow and like give you a better explanation with better examples? Does that help, lads? I'll drink some water till then. Nice. Nice, bro. And this is important for cloud too. Like you, once you understand subnets well, you will actually be like really prepared to like work on cloud, because cloud is all about subnets. There's so many networking thing happening in cloud. And as an engineer, you have to set up so many networks. Okay, we have routing. I think we will be just covering this task today. So let's work on, let's reread again to understand, right? We presented earlier an analogy stating that a public IP address is like your home postal address, right? The up If I'm outside and using only a mobile, using mobile data, we don't have any router there. Then how is the communication taking place to the internet? Good question. You don't need router. Basically, your phone is doing all the communication. Nice. Thank you. So, let's say if you're outside, this is your phone, right? This is your phone, right? With internet or whatever, right? This is your phone. When mobile data is on, it's actually looking at the nearest. Then it has its own public IP. It has its own public IP address and it's talking to a nearest tower. Nearest tower, basically. To put it in simple words, or depending on, it might be talking to a satellite at this point, I will say. Yes, like a cell tower. There's ways it can communicate, but like easiest answer is yes. A cell tower or a satellite. Right? However the connection is set up by your company, it can be talking to any of these. There is no router required because you are just one address. Remember, in this case you have one address. Imagine a house with just one room. Then there is no public IP addresses, no router needed, right? If there is just one device in the room, there is no router needed. It is going to be just one router in the house, or just one device in the house. Sorry, if there is one person in the whole house. Does it make sense? That's the whole game in like using data. Just one person in the house. You don't need like to send the letter anywhere inside, right? If there is only one person living and there is just one room, you get the letter, right? Where does the letter go? When you see it just stays there. It's the same room. That's the same idea here. You're legit directly talking to the internet. You actually have a public IP address at this point. Yes, comes directly to you. Right? If there is one person living in the house, who the postcard, the postal letter will be addressed to, right? You. It's not going to go into any room. Same thing with the same here. Like, it's just one device connected to the internet. Is that like helps? Does that answer your question? Hopefully it did, right? Oh, awesome. Beautiful, bro. No problemo. Okay. A private IP address. I like these questions. Do ask these questions. I like this. This is a great question. A private IP address is different. The original idea is that it cannot reach or be reached from the outside world. Nobody can address like, hey, room, third room on the top, on the second floor of the house. This address is for that person. No, right? You say it's addressed to 123 Washington DC, something like that. It is like an isolated city or a compound where all houses or all rooms are in apartments are numbered systematically and can easily exchange mail with each other. Just like inside the house, you guys can talk. Your parents can talk to you. You can talk to your siblings or your partner or your kids, but not to the outside world, right? You don't have to like show to the outside world. You don't have to go outside the house to talk to them. For private IP addresses, and you cannot talk to the outside world. I cannot talk to Sri Ram because he's in India. I that communication has to go outside my house, right? For private IP addresses to access the internet, the router must have public IP address and must support network address translation. We'll talk about that later. At this stage, let's not worry about NAT, how NAT works, and we will visit later in the module. We do. Before moving on, I recommend memorizing the private IP address ranges. Otherwise, you might see an IP address such as 10.133 and 7 or 172.31 33 and 7 and try to access it from public IP address. What you just have to remember, I will say this, right? If it starts with 10, if it is starting with 172 or 192, right? Or 192, 168, right? These are the numbers. Just remember these 10, 172, 16, 192, 168. These are the only things you have to remember. I personally, as soon as I see 172, 122, 168, and 10, I just, more you play, you will realize like it just becomes a muscle memory. So routing, we can complete this fast. Routing, a router is like your local post office. You hand them the mail parcel and they would know how to deliver it. If we dig deeper, you might mail something to an address in another city or country. The post office will check the address and decide where to send it next. For example, if it is to leave the country, we expect one central office to handle all shipments abroad, right? What does this mean? Do you guys understood that part or do you want me to explain? Was that like clear or no? Yeah, understood. Okay, cool. So basically, if you are sending something outside, right, there would be one main postal like headquarters from where outside things go because whatever that's the easiest way, right? But it's inside the city. Let's say if you're going from point 1 to point 2 inside city, there are many ways. Post office, right? Google Maps do the same, right? Here we talked about Google Maps. There are so many routes. Let's say there are so many routes available. Let's say if this is address A, this is address A, this is address B. There are many ways it can reach. Post office is their job to find what is the best route, just like Google Maps if you want to go from point A to point B. Same idea, right? That's routing. when we think about it. That's the same idea when packets are being sent from your computer to another computer, they're being routed best possible route. If we dig deeper, we might blah blah blah. In the technical terms, a router forwards data packets to the proper network. Usually, a data packet passes through multiple routers because it reaches its before it reaches its final destination. When we are going from, let's say, the first path, we go through many, like, let's say, corners, go through many roads, checkpoints, whatever, right? We go through many roads, many checkpoints. So packets travel through other routers as well. Yes, that's how it works. Yes, exactly. Basically, let's say if you want to reach one place to another, you go through many roads, right? Many routes, many roads, sorry, right? Many different roads if you want to reach one particular, let's say, another way, let me think about it. Okay, so in school, right? In high school, holy, that's a lot. In high school, where can I go? Is there a. Okay, here. In high school, right? Just like there's a like if you want to go from point 1 to point 2, or you want to go from grade A to grade 12, you have to go to second, third, yada yada yada, 10th, 11th, 12th, right? Same thing, I'll say, or one. Actually, I have a really bad example. This is a really bad example I gave. If I want to go from India, from Canada to India, right? Canada to India. In India, let's say I want to go to a very remote city which don't have any international airports. India. Inside India. I want to go to, let's say, Lucknow. Let's say Lucknow doesn't have an international airport, and here in Canada, I belong. I am living in, let's say, let me think, a city which doesn't have international airport. Queensway. Let's say this is not the correct name, but let's say if there is a name, right? This is, or another, actually, I have a good one. I don't know if you guys know this. Let's say if live in London. London is actually a city name in Canada. Just letting you know. So let's say I live in London, right? It doesn't have an international airport. I want to go to Lucknow in India, which also doesn't have an international airport. How things will work? First, from my local airport, right? From my local airport, I have to go to a international airport in Canada, right? Then from there, I go to, let's say, another one, because let's say, there is no direct flight. So either I can go to England, I can go through China, only where the Canadian International Airport is connected to. Those are the only airports I can go through, right? China, let's say I took England, right? Then I went to, let's say, Delhi International Airport, India's international airport. INTN means international. Then from there, I went to Lucknow's local airport. Now, instead of England, I can go to China, right? And then to India. But I need to take certain stops. I have to go through certain stops because there is no direct connection between London and Lucknow airport, right? Similarly, our packets, let's say instead of me, it's my network packet who wants to go from London city, where I live, to Lucknow, where Sri Ram lives, right? You live. So that's router in London to a router which in Canada, which is like connected to an international router, then to England, another international router, India, another international router, to a router in Lucknow, which is near your house. Does that make sense? How things work? Nice. Okay, good. I wish I was able to animate these things. Would be so much better. Awesome. Thank you, bro. And thank you for asking these questions. These are good questions. Actually, it brushes my brain and explanation skills too. Thank you. So in technical term, a router forwards data packets to proper network. Usually a data packet passes through multiple routers, like for in our case it was multiple airports, before it reaches its final destination. The router functions at layer 3, inspecting the IP addresses and forwarding the packet to the best network router so that packet gets closer to its destination. Layer 3 is the one responsible for this routing capability. The routing is a feature of layer 3. Remember that. So let's say it is your mobile user for your company. This is your office user and this is your web browser, right? How things work, let's say if you want to update your browser, let's see if this will work. Okay. If you want to update your web server, right, it goes through the office. Let's see, better one. It goes through these routers and then web server. But let's say a mobile user wants, right, to talk to your web server. It will send the packet. It can go in any direction, takes the best direction, goes here, web server responds back with this, right? So it passes through multiple routers. That's routing, finding the best possible way, because this is a longer way to go, right? There's so many ways, but finding the best way, that's a feature of layer 3. Now let's look at 2 questions we have, right? And we'll end today's stream. Which of the following IP addresses is not a private IP address? Lads, you guys have to tell me this thing. Which of these is not? Actually, let me ask you this. What are the 3 private IP addresses? Third one? Yes, sir. Tell me the CIDR of the 3 IP addresses, lads. You have to do me that favor first. What are the CIDR notation for the 3 IP addresses we have? One was 10. Let me remind you a little bit. One was with 10, but only the 8, right, were there. Then was 172 dot, I think, 1. I don't remember this one. This one was just 16, I believe. What was it? 172. 16 here and 12. 16 and then 12. 192.168.12 again. Oh, sorry, 16. Does it have to be 16? I think I've seen better. Okay, that's fine. But I think, yeah, just remember 192, 168, not 168, 192, 172 and 10 are the ones which starts, right? Now, they are a bit confusing. Okay, don't worry. I will find a way to give a better explanation in the next video. Okay, don't worry, I got you, bro. Which of the following? Let's complete this, and I will we will end today's stream, and then I will come up tomorrow, and we'll do a better explanation of CIDR. This is number 3 as well. Oh, awesome! Thank you, lads. Is not a valid IP address. 305, yes. Awesome. Good job, lads. And also, we are actually very close to our 600 milestone. It'll be sick. You know, actually, I planned something for 750. I have a gift ready for myself once we do 750, which will actually increase how I do explanation videos, will make the quality better. Almost there. Another one. Yes, sir. Did we got it already? Who knows? It's all good. 750 is a nice milestone. I'm actually very excited about. But okay. With that being said, this was it for today, lads. Thank you so much for joining. Sorry, I got late. I was just honestly, I was so stress free today. I forgot to put the alarm, set the alarm, and I just overslept. But tomorrow this won't happen. Tomorrow I will come at 7 a.m. my time, so that would be around 8:30 p.m. India time, and we'll do a longer stream for around 2 hours and try to complete the UDP encapsulation telnet, and we'll work on subnet explanation, the CIDR a bit more. But till then, thank you so much, lads. Oh, did we do that? Oh, yay! Thank you. We got 600. Yo, let's go. Thank you so much. Thank you so much, man. Thank you. We did it. That's awesome. Thank you. This is big, man. This is big. Let's go, baby. Hell yeah. Thank you, Ghost. Thank you. Awesome. We did it, lads. 600. That's awesome. Thank you so much. This is big. Thank you so much, lads. Soon we'll do. Also, I was looking. We got more subscribe, the sponsorship thing, right? Remember, we'll do that so that during the holidays we can do a bigger giveaway. I was talking to Rover. We'll do a big giveaway, or at least more frequent giveaways. So I'll start the sponsorship from tomorrow as well. So thank you so much, lads. A big thanks to goes for helping with the 600 last sub. I like the fact I'm able to witness this. Thank you, Rover. Thank you, Shriram. Thank you, Wrench. And thank you, everyone who was there. Big thanks. And I'll see you guys tomorrow with another great stream. We'll talk about, and tonight we will do lead code ones, so I'm excited about those. Till then, thank you so much. This is your favorite neighborhood hacker, the sniffer of packets, the biggest, the best, the person with one of the cute smiles on internet. Thank you so much, lads, and a big bye. Bye, everyone. Thank you.